The success of my PhD is dependent on good research. So once my plants are sown, I really care for them and I want them to do well and perform well. And yeah, I do come and check up on them to see how they're doing. I'm Louise Logie. I'm a PhD candidate at the Laboratory of Genetics at Wageningen University and Research. I started in Wageningen as a bachelor student in plant sciences, and I pretty quickly specialized myself in genes and health. I followed up with a master's in plant biotechnology, in which I took the specialization functional plant genomics. And during my master thesis, the work was going really well. I was working on photosynthesis as well. And I decided, together with Mark Aert, to write a PhD proposal, which got granted by the NWO. And that's how I ended up working here. So right now I am identifying natural genetic variation in Arabidopsis thaliana. So I'm looking at closely related plants that respond differently in light fluctuations. So from low light to high light and from high light to low light, photosynthesis rates vary, and I'm identifying genes that cause this difference. The aim of this research ultimately is to figure out how to increase photosynthesis in plants. This would lead to plants that function better under the same amount of light as they do now, but will also provide guidelines for breeders, for instance, to increase their crops through breeding. In Europe, we're not allowed to use GMO, and so having natural variation that increases photosynthesis is very important. So before NPEC, I used a really small phenotyping platform where I could measure about 20 plants simultaneously. Now being able to measure 1,296 plants, that's a really big upgrade compared to what we had before. We also had systems where we could measure plants one time at a go, but then go really specifically into the photosynthesis. For my research, however, these replicates are really important, so NPEC is essential for what I do. In G6, we are able to expose the plants to many different light treatments. So we can expose the plants to steady light, which we've been doing in the lab quite a lot. But now we also have the technology to expose the plants to really rapidly fluctuating lights. So we can simulate cloud movement, leaf movement, sun flex even inside of the chamber, with certain limits, of course. And being able to do this and measure photosynthesis at the same time is a really nice tool to phenotype photosynthesis and get this data on all of these different plants. This chamber is also capable of doing modulated light measurements, which is a new and exciting phenotyping system that hasn't been worked on a lot. And I think combining these two together is a really strong tool towards better understanding photosynthesis. From the genetics group, we have a pretty tight-knit group that works on photosynthesis, and we're all users of NPEC. And so being able to share our knowledge and our experiences together really helps us increase the quality of our work overall, I think. So the team is really important. And then also the guys that are actually taking care of the plants are essential for what we do.